developing aerospace alloys and manufacturing processes. He has a degree from material science from MIT, as well as degrees in civil engineering, mechanical engineering from Duke University. He's been awarded the NIST Diversity Award for his work on staff development and outreach. So with that, I'd like to introduce Frank Gayle. He's going to have a talk on NIST, Semiconductors, and the Chips and Science Act.
Thank you so much. It really is a great pleasure to be here and to be up at Binghamton. It's my first trip here, and good to see Bill Chin on his home turf. He's been such a great help to us over the last year or so, and as we were developing our plans for the CHIPS Act. I have to start off saying these are exciting times. As you could see from Jin's talk, that alone shows that we're in exciting times for packaging and for microelectronics overall. And I also, we're from the Department of Commerce, and we're extremely pleased about the Build Back Better Award to Binghamton in the battery area. And building that ecosystem and developing manufacturing practices along with the fundamental research is really a very important area for the nation. And so we're really very pleased about that. And how's that sound? Is that better? Okay, that is really close. So I also want to mention my collaborators, Robert Rudnitsky and Dave Seiler, because we've worked very much as a team on this work that you'll see today. So for those who are not so familiar with NIST, we've been around 120 years now, started off as the National Bureau of Standards. And we work both with, we do everything from rather fundamental work, resulting in 5 Nobel Prizes to date, but we also do, everything is targeting industry, how we can support industry, and that's done through metrology or measurement science, standards, and technology. And our goal is enhancing economic security and improving quality of life. So as I said, we work very much with industry across the whole swath from fundamental to applied. Even our work, like the Nobel Prize work in low temperature physics, has resulted in timing capabilities which allow GPS to work. Without that fundamental work, we wouldn't be able to use GPSs as we do today, but it's all oriented towards industrial application ultimately. We also have a leadership role, a global leadership role in standards. Most recent big effort is in National Standards Strategy for Critical and Emerging Technology, and that's standards for artificial intelligence, for quantum, for semiconductors, and a whole swath of other areas. We have a long history in microelectronics. We played a very close role with Semitech during the early days in metrology, and there was, as you may recall from the Semitech roadmaps, there was a large portion of it was on metrology, and NIST contributed a great deal to that. So the metrology is still going to be a very big issue, metrology and standards, as we move forward in microelectronics. So as we are moving forward, part of the CHIPS Act also includes work at the NIST labs, and so we'll be working in all these different areas, foundational metrology and standards being key parts of it. So now to the CHIPS and Science Act. As was mentioned earlier, this is a once-in-a-lifetime opportunity, and it's both a tremendous opportunity in direct support for industry and very substantial for universities and other research organizations as well. Our goals are pretty broad with this $52 billion program. Really the goal, the driver, was increasing capacity in domestic semiconductor manufacturing. And the all the supply chain weaknesses that showed up, particularly during the pandemic, that really spurred the passage of this act. And those are issues that we'll be addressing. And that's really going to be what success is viewed as if we fix those supply chain issues and the domestic manufacturing. Also, more in the R&D side is the manufacturing innovation part, and I'll go into more detail on all these areas. And as you'll see, workforce development. So we've been preparing for the CHIPS Act passage for a long time. And so it's very exciting that it passed. We have an industrial advisory committee, which hopefully will be announced in the next couple of weeks. We're doing some, the secretary is finishing up that final selection right now, Secretary of Commerce. We've had an extensive request for information that was put out last fall, and I'm sure a lot of you contributed to it. We got a great deal of very useful information from the ecosystem. And then we've done a great deal of planning, as you'll see. One, we had in the NIST labs, we worked getting input from stakeholders on metrology needs that are anticipated in the semiconductors and in packaging for the coming 5, 10 years and out, because that's the sort of the area that we work on typically at NIST. Had tremendous participation both from industry and academia, and also good from government as well. And just this past week, we put out 2 new reports out of NIST, and one is on our RFI that was done to get input from all stakeholders, and also the summary from opportunities in metrology and standards that was done at the NIST labs. So those 2 reports just came out last week. Here's where we stand. Here's where the meat is in the legislation. And it's a total of $52 billion. $2 billion goes to the Department of Defense and $50 billion to the Department of Commerce. There was, of course, a lot of question about what agency should be managing the CHIPS Act program. It came down to the Department of Commerce because the real issue is the economy of the nation and support of industry writ large. So the incentives program is the largest part of this. The incentives program is it's $39 billion, and those are direct funds or grants or loans to industry to increase capacity in the U.S., and it covers all areas. Most of the airtime has been given to new fabs and new cutting edge fabs, but it's much broader than that. It includes legacy nodes as well, and packaging, and all aspects of the supply chain. The other, the R&D part of the program, which is Section 9906 of the CHIPS Act, has 4 different components, and the National Semiconductor Technology Center focuses on fab level integrated circuit production and research. The packaging program is actually the largest program at $2.5 billion in fiscal year 2022. And these numbers were designated by Congress as far as the splits. Microelectronics research at NIST and then Manufacturing USA Institutes are at $500 million in the first year. And the out years are another $6 billion, making a total of $11 billion. And that split is yet to be determined, but we will make that determination inside of the Department of Commerce. There was an announcement yesterday by the Secretary of Commerce at the White House that it's been decided that all of these programs will be led out of NIST. Legislation said that the last 3 programs would be out at NIST, but it's now been decided that all of it, due to the NIST technical expertise and our past history with managing grants, that the entire program will be out at NIST. So our work, our team has focused mostly on these last 3 programs, and particularly on the packaging program, planning for that, and the Manufacturing USA Institutes. But we're working on with the entire overall team on the whole program. So it's been a bit of a challenge, actually, to convince people that the CHIPS Act is not just about the chips. Everybody thinks of computer chips. The car companies can't get their chips. That's what they say, even if it might be a substrate shortage or packaging problems. And to tell you the truth, unless you're actually in this field, you don't know what packaging is at all. And people do know that we've lost our share of manufacturing in the US. Like I think it was about 30% in the 90s, and now it's down around 12%. And that's for fabrication of the integrated circuits. And then the packaging question, that's, you know, we have a manufacturing problem, yes, but we have a real packaging problem. And that's pretty much either here or in Asia. Manufacturing spread a little bit broader across the world. So, and along with where the manufacturing is, there's a lot about the ecosystem as well, because it tends to be where the innovations are, where the manufacturing is. Quick feedback, and the ecosystem develops there. But we do have some great strengths in packaging research, and Binghamton being a great example. So although Amcor is headquartered in the US, there are no manufacturing facilities in the US. So one of our goals in the CHIPS program is to get a few more dots here in the US as part of our supply chain. Part of our education program about what packaging is, because first of all, people don't know what packaging is, and second, well, what's advanced packaging? To tell you the truth, this is where I started in packaging back in the 90s, developing, you know, how are we going to get the lead out of the solders for attaching our packages to circuit boards. So this is actually a slide I used to explain what is advanced packaging. So advanced packaging is an enabler. It allows just tremendous, it allows your smartwatch, it allows so many new opportunities, and we've just barely started on packaging and what it can do as far as capabilities. So it's a very, it's a very exciting field, and this sort of graphic here does seem to be effective at conveying what is advanced packaging going to do for us. You know, that perhaps Moore's law alone is not going to be the tremendous enabler for many of the products that are coming out. And, you know, here we can get everything that you see here on the right side, all in this little tiny package that you're wearing on your wrist, or perhaps wearing on flexible electronics, putting the chips directly on a little piece of plastic, which you might put on your body and measure all your different vital measurements. So as we've given out some road mapping awards out of our office earlier this spring, and I like this example from our award to SRC, which has a lot of industry and universities involved in this planning. It's road mapping for packaging coming up. And, you know, this is very exciting. I like this sample here where you can see multiple chips. You know, you can see maybe easily see 5 chips on top of this board. That's an exciting new development compared to where it was many years ago. But more exciting perhaps is that inside the substrate, there are an additional 10 chips. So there are just so many opportunities and that we're just a lot of low-hanging fruit in the packaging area. And so it's a very exciting, but then we have this kind of crazy stuff that's coming, and it's going to provide so many opportunities, new capabilities. Boy, I apologize about this. It does have to be really close. So I do want to transition a little bit to workforce here, because in all of our outreach, we talk to everybody out there about what's the technology, what should the U.S. be looking at today and 5 and 10 years out? What should we be prepared for as part of our CHIPS R&D program? And a lot of great input and concepts, but then you go to the question about how about workforce? And this is what we hear. And if you ask the direct question, you know, what would be the most value for the nation? You know, if we had to give up the technical R&D, if we were going to get all the workforce we needed, or give up workforce and do the technical, it's a tough call, because the workforce shortage right now is such an issue, keeping people when they graduate in microelectronics. And then also, as we're getting a whole lot of new capability as part of the incentives program, who are we going to have to work in those facilities? So actually every aspect of the incentives program and the NSTC, Manufacturing USA, and the packaging program all have workforce part of them and as part of it. And so that will be a big part that we are taking very seriously. The US has a number of unique opportunities that we plan to take advantage of. One, we have 200,000 returning servicemen every year, and that's a largely untapped resource that that we can take advantage of. There are many there are minority serving institutions that we can take better advantage of. The underserved rural and urban communities, I should say, overlaying all of the CHIPS Act, both by the legislation in the wording in the CHIPS Act itself and by executive orders, is that we have two big things that have to be considered in every action that we take. And one is the underserved communities, and the other is the environment. So keep that in mind as you send your proposals in or whatever in any aspect of CHIPS Act funding, because it's a requirement, and the guys who are giving out the money are going to get graded on that. So you want to take care of them, make sure they find it attractive. Manufacturing USA, we have a number of institutes there. I'll talk a little bit more about that. We have some proven programs in workforce development. Also, the foreign nationals here, almost half of our engineering students in the US are foreign nationals, and there's a good opportunity there. Some people would say it's a choice we have to make that would probably be of minimal cost in order to improve our workforce situation. Another thing, there are just so many new efforts going on around the country, as you can see on the left side of this graphic. And this is just a small part of it. So we see a lot of opportunity taking advantage, coordinating these. We see CHIPS Act funding can be a catalyst for all of the workforce efforts that are ongoing right now, and new efforts that will be supported by both state and private funds. So here's a sort of a synopsis of the description of the R&D programs in the CHIPS Act. The National Semiconductor Technology Center is pretty well defined. Well, it's defined a fair amount. There's still a lot of open questions about it. The packaging program is not described as a center, it's a program. That leaves it wide open. There's less description in the law about what needs to be done under that program. And so that gives us a whole lot of flexibility. And that's why the input from the stakeholders around the nation is so important. Manufacturing USA, it's up to 3 new Manufacturing USA institutes. And we have a model for that. We know how to get funding out for those, and those will be supporting areas in semiconductors and packaging or bridging the gap. And soon we expect to have requests for information published, hopefully in the next week or two, that will be soliciting input on the Manufacturing USA Institutes. How should those be, what topical areas should they be considered? Should they be addressing something, gaps between the NSTC and the packaging program, like co-design or automation or something like that? So we look forward to input from all of you when that request for information comes out. And then the NIST internal programs Congress knows what we do. That's going to be in measurement science and standards. So Manufacturing USA is a program across the Department of Defense, Commerce, and Energy. There are 16 institutes at present. There are a number like AIM Photonics and NextFlex and Power America, which work directly in packaging, and a number of others which they're in related technologies that can be supportive. And so the CHIPS Act, as passed, actually included that there can be support for the existing institutes in addition to standing up the 3 new institutes. So the model for Manufacturing USA Institutes, in case you're not familiar with that, is the goal is to develop manufacturing technologies that are that bridge the valley of death between fundamental research, develop the manufacturing technology so that the inventions and innovations here in the U.S. can be manufactured in the U.S. rather than either dying in the labs or going overseas for manufacturing. And in part, semiconductors suffers a little bit from that, about inability to get some of these things scaled up in the U.S. And it's a little easier often for innovators to get it done in other places in Asia. So this sort of thing can be a big help for that. It's a coalition between academia and industry, typically industry-led as far as the type of project what you're addressing in manufacturing technology. And typically there'll be a shared use facility that is available for the project work and for small companies, large companies, and startups to do processing of materials. And a number of the big institutes are very good at that. You might be familiar with NextFlex, Pilot Line, and AIM Photonics, et cetera. As I mentioned, we do have this request for information coming out, and it addresses all these different areas, and we would appreciate your input on this. So how do all these programs fit together? Well, this is one scenario that could be how it is. We have a lot of fundamental work that is done here in the US, supported by the National Science Foundation and DARPA and SRC and others. The National Network for Microelectronics R&D is actually the $2 billion program that is going to the Department of Defense. And then we see the big R&D programs, the National Semiconductor Technology Center and the packaging program, and Manufacturing USA is bridging this valley of death up to production. And that's what will be supported by the incentives program, the $39 billion large program. So lastly, yesterday, the Secretary of Commerce was at the White House and had a press briefing and released our strategy document at Commerce as to how we're going to approach the program. So this is our first public statement. And I encourage you to go to chips.gov, easy to remember. And you can take a look at this document. There's a lot of good information in it about how we are approaching. This is our initial approach to all the programs here. And that concludes my talk. If there's time, I'm happy to take any questions.